So my name's Jarvis. I'm one of the project managers here at DuoProjects. We've been involved in the project for a bit over 2 years, and I wanted to give a bit of a discussion today focused mainly on the task that Trobe University set us in terms of what project they wanted. Having a look at, before we got Multiplex on board, how we looked at the program and the challenges that we faced, and then touch a little bit on construction and what's been delivered to date. And there's a current picture of how the site progress is currently looking. And you can see that the render versus this is actually looking pretty good. So early March 2018, LATROBE asked us to give them a hand with doing some due diligence and looking at some options at the site. They were finding that 70% of their undergraduates were first and second year students were staying on site. So that represented sort of the demographic of their cohort. Most of them came from regional Victoria, and they were finding that their current student accommodation was nearing capacity. And so they asked us to help find them the suitable site in which they should do the development for what was to be 2 stages. Stage 1 of being approximately 600 beds, and then a further 400 to make up 1,000. The vision that they had was long-term. They were hoping to house about 15% of their students on campus, which approximately equated to about 6,000 students. And they were looking to create sort of precincts and neighbourhoods. So they had Glen College and Menzies College and a college-based system. They were hoping to sort of expand on that sort of way of student life. So as a bit of a project overview, the project is 624 beds. The project value is approximately $100 million. The last student accommodation that LATROBE did was the 1960s. So you can imagine what that was like. It was also LATROBE's largest project by value that they've ever undertaken. So it was extremely significant that they did a good job here. The project itself employed 500 direct and indirect jobs to deliver the project. 5-star Green Star was an aspiration for design and build. The objective for the university was, due to the projected shortfall of students coming into campus, they needed this project to be designed and built as fast as possible. And the result of that was a timber structure with approximately 4,100 cubic metres. And we think it's about the second largest in Australia and potentially the top 5 in the world, but who's counting? So in terms of the design objectives, LATROBE really wanted something that was sustainable. They've got a sustainable ethos about them. They wanted everything to feel sustainable and be sustainable, fit in the environment, which is sort of a quasi-bush campus where there's a lot of gum trees out there. They wanted to try and reduce their reliance on air conditioning and try and see if they can increase the building performance in a passive sense to achieve a reduced energy reliance overall. They wanted to try and retain as many trees as possible, which is a bit difficult in a site that was full of trees. And when we got to the decision to go down the CLT path, it was tried to look at exposing as much as we could, which is another design challenge for the team. So I just want to talk a bit about how we got to going to timber, because it wasn't a decision that we went straight away. It sort of happened in the later part of schematic design. And for the schematic design duration was actually designing a concrete and timber building in parallel. And so when we were completing schematic design, we had to really look at what were the risks in delivering a project of mass timber this size and scale, considering the supplies available and everyone else. So JCBA architects were already doing a mass timber building. They were experienced in it. They were pretty confident, but project managers, we had to go through a program process to make sure that we would be able to achieve the program that LATROBE set out for us. using mass timber, and we also had to just make sure that the sustainable, the sustainable scale of this was actually going to apply, and then we get the best environmental outcome for everybody. So the first thing that we looked at was the expected environmental impact. So we spoke to our ESD consultant, and they gave us some case studies, and they showed that approximately when we were using CLT in a project compared to a reinforced concrete structure, it has a considerable global warming potential reduction. So straight away, we were convinced of the environmental impact it was going to have, and it was going to be far greater than any other sort of tool that we could use in terms of, you know, going to 6-star Green Star from 5-star or anything else. So we're pretty convinced of the environmental benefit by that point. The next thing that we did was we had to sort of canvass the suppliers, and we actually approached Wood Solutions at this point and asked them about some more detail of what we needed to know and who were the suppliers that would be candidates for the project. And we formed an expression of interest and went out across to global CLT manufacturers and got different durations from each and tried to break it down into a program basis to work out approximately when you start your drawing process to your first panel on site, how long is it roughly going to take? And from that, we sort of took an overall average of 27 weeks is the time frame we considered. And then we distilled this into a program. So this was our baseline program. It was a concrete program. It was the fastest program that we thought we would be able to do in the timeframes that we were given. And we had to compare it against a mass timber program. And so we did 2 program analysis. And the difference was about 1 month to 6 weeks, with concrete actually being faster based on the inputs that we had and we assumed. And effectively, the problem was that if you imagine 2 buildings going from contract award, on a concrete structure building, you do all your piles and foundations, which takes a fair bit of time, and then you start building slowly your concrete, and you're having to prop along the way and everything else. If you compare that to a timber building, the timber building actually can be built faster, but there's a longer period of time to get from placing the order and actually being able to do those shop drawings to on-site, which is 27 weeks. And so we were finding that even though by the time the CLT would arrive, a similar concrete building would be well underway, and the faster install time wasn't actually enough to catch up. And so that's sort of where we were in the middle of 2018, seeing that it was actually comparable, but what we couldn't actually prove that it was faster. So then we actually looked at, okay, well, what options could we do to make this faster? Can we challenge some of our program assumptions? We looked at, well, could we actually design bathroom modules so they can slide in either in a through a goods lift or through the facade in some way to actually speed things up, so you didn't actually have to load a floor plate. You could load it later. So try and get more things off the critical path. Can you actually try and take the facade manufacture off the critical path as well? And then maybe can you load plaster and other finishes onto the floor to see if you can actually just decrease the lift time in terms of using the hoist for the alleymac. And ultimately, where we landed was that the overall overriding factor that determined the CLT use on the project is really the client's preference for it. It was supported by the design team based on high sustainability, aesthetics, amenity, and the healthy building aspirations. We also found that the cost of the CLT option is affordable for the project, because it's never an apples for apples situation. It's more of a value proposition. And also the program duration is comparable to that of a concrete structure. You also need to remember for student accommodations, unlike residential or commercial, you're trying to deliver to a semester. If you deliver a building in the middle of semester, no student's going to come in and change their student accommodation in the middle of that semester. They're going to do it at set points. And so if you can deliver something a month earlier but still meets, say, the start of a semester 2 date, then it achieves its objective in terms of program. But there were some key considerations that we actually needed to incorporate from that timber design. So the first thing was, in terms of maintaining the program, we needed, as a group, to give some direction to the design team of what was actually important to document. You don't need to document every single finish of paint colours. You don't need to document every sort of facet of the joinery. The main thing that was driving the program in this project was the CLT design. And so every design input in terms of penetrations and coordinations was key from our perspective. So we were constantly pushing the design team to try and make sure the design was as coordinated as possible, but allowing the design team to resolve some of the other design elements at a later date. It was really important that we had an architect and a design team generally to have familiarity with mass timber, and we were lucky in the architect that we already picked, JCBA, had that experience. So that gave us a lot of confidence to be able to go down this pathway. And then for the tender process, we needed a contractor with both design and construction experience in delivering mass timber. We often find that some of the contractors are great in delivering construction, but lack some of the design upfront part that really adds value to the project. So overall, what was really important to us is we can't just burn time trying to work out how to build a timber building. We need experienced people who know what they're doing to get on with the job as soon as we can. The other thing that we had to do was alter the procurement approach. So the Trobe University had a set method of how they could procure buildings. They could do it under a D&C or a fixed lump sum environment, but they didn't allow an early contractor involvement contract per se, where you get someone in quite early and help sort of flush out all the design and work with the mass timber. And mass timber, from our perspective, is a bit different from concrete and from steel, in that concrete you can form to place and it's a bit more malleable, and steel comes with, you know, steel schedules and everything else. Mass timber does depend a little bit on manufacturers' methods, and so having involvement with the suppliers early through a contractor, we felt could yield the best result for the project. So what we did was we opened it up a bit. We sort of did an ECI quasi-VM process during the tender, where once we got to our preferred two tenderers, we did an open table discussion with the two preferred tenderers and said, what could you change? How can you optimise the design in order to give LATROBE the best outcome possible? And allowed them both to workshop their ideas with the design team and come up with the best and final offer that incorporated those design elements and could be reflected in the overall final project.
Jarvis, keep an eye on time, please.
No worries. Okay, so the last couple of slides, I just want to talk about the build quickly, but a lot of us will be talking about it anyway. So in terms of the carbon footprint for structure, we actually found that the actual, this was the original benchmark that we had previously. And when we added up all the different elements, we actually found that our overall global warming potential reduced by 76%, which is against the 52% expected based on the case study. So that was a great result from the carbon perspective. And all of this is some statistics of what that actually means, because it's hard to work out how much greenhouse gas is in a practical sense, but there's some figures for you guys to understand. The early mobilisation result, and I talked about our 27-week period that we assumed previously. Well, the actual result was much shorter than that. So there's some approximation in some of those figures, but Multiplex and the design team achieved a far better result in terms of getting the design started and then getting the first part on site, which made a massive difference. The floor plate times I won't talk too much about, but they tended to be about 2 to 3 days quicker than what a similar concrete student accommodation floor plate was. And the overall program is, well, it's ongoing. So COVID-19 has put some niggles in the road, but the team's doing really well to go through it, and we're saying it's still on track at the moment. So a couple of key takeaways. From our perspective, you can design and build as fast as you want, but it doesn't mean you should. It put a lot of pressure on the design team to really think outside the box and deliver as fast as they could, but it also put a lot of stress on a team. And unless it is your absolute key driver, I wouldn't recommend it, because it does have some trade-offs. My perspective is that the project was able to achieve the fast track program because the key people involved understood the process well and knew what was needed. They were able to utilise this experience, which meant that faster approaches could be taken across all stages of the project. And from my perspective, the design team is really what made the project what it is and was able to achieve the dates. But we found that utilising mass timber really just compounded the results and allowed for even faster times than we actually thought. So thank you very much.
So I'm Simon Topliss, Associate Director at Jackson Clements Burrows. I've been on the LATROBE project from the original tender submission to LATROBE, and DuoProjects were involved at that stage. And it was actually out on site yesterday morning with the team, looking at a couple of defects issues as we sort of edge our way closer to construction. So I'm going to sort of try and walk through just a very, very high-level summary of the design. Some of the guiding, I suppose, of the mass timber thinking that given that we had already had experience in a mass timber build that was actually on site, we were able to bring some of that sort of guidance to the project. And then looking at one of the sort of more interesting details, mass timber details, and how that actually eventuated and what was the key sort of reasoning behind that and that process. So at a very high level, the timeline for the project, Jarvis has alluded to it really well. This was a fast break project. We were appointed around the start of June 2018. September 2018, we completed our schematic design, moving to a sort of two-stage tender process, which Jarvis has obviously already alluded to. In March 2018, we worked through the CLT design issues with Multiplex and XLAM Dolomiti in order to have panels on site by July 9, 2019. May 2020, and that photograph was from a week ago. We're edging towards construction and hopefully looks like we're going to be on track to complete towards the end of June this year, obviously in about 6 weeks' time. So an incredibly compacted timeframe, but quite frankly not one we're unused to in the industry at the moment. So for the master plan, and Jarvis has alluded to this, just get rid of this bubble. We were working on stage 1 student accommodation, which was part of a much larger scale master plan to the campus. And so we had to be aware of some of the design controls within the master plan. We were sited beside Glen College and Menzies College, which are the two of the residential cohorts on campus. 60s buildings probably had seen better days, but have some really good qualities to them. One of them is a really interesting sort of cloistered courtyard in the centre of the buildings. Our site was beside Glen College, which we can see in the right-hand photo in the image. This was a really well-established landscape site. There were a couple of tennis courts on the site, but some useful eucalypts. And I think this was, the really joy of working in a bush campus setting like Bundoora Campus that's been there for 30, 40 years and very well-established trees. So all of that original sort of design thinking really needed to centre around one of those, the retention of as much landscape as we could. Understand the connections across the site, the adjacencies, what it was now and what the site would be in the future at the end of the master plan. Understand the public realm aspects on the site, the residential amenity, obviously the solar aspects to the site, how massing and form could sort of move across the site, and how the building be articulated in relation to those street edges. So out of that, some very, this is very early form studies. I think this was concept design meeting number 1. We knew we needed 600 beds on the site, which meant we were looking at some very, very large buildings. So those initial studies really talked about, is it 3 buildings, 2 buildings, or 1 building? Really as simple a discussion as that, and what qualities could those bring to the site? And it became sort of clear in those early discussions, 2 buildings was what was probably going to optimise the overall design, and looking at 2 300-bed buildings. And out of that, 3 options started to develop. Option 1 was a street edge option, we called, which sort of had sort of very conventional type student accommodation building, which hugged the street edges, which was quite closely aligned to the sort of master plan thinking. Option 2 started to sort of soften the corner and introduce the sort of curved geometry, which you might have now seen in the building already. And then option 3 was this sort of idea of the twin curves, 2 buildings that were essentially twinned, that peeled away from the street edges and the existing and their residential colleges beside us, and created this really wonderful courtyard in between the 2 buildings, and really interesting sort of interstitial spaces around the buildings, and introduced, we thought, a really interesting geometry to the campus. So through the concept design, we sort of really analysed this in more detail, looked at the outcomes, the connectivity through the site, the retention of landscape, how many trees we could actually save on the site, the spaces, the public realm experience, the interest that the massing and form started to produce, the residential amenity, which was really key, which was about minimising those south-facing rooms, which is, I think, is always really key in student accommodation, and the articulation of the site and how you would sort of move through. And the sort of the forms and the building and the massing on site, which there's a lot more to tell on this, but it's really started to look promising for us. And so through schematic design, the buildings developed into these 2 300 beds buildings, essentially twinned, and that was really key. That was really key to our design thinking at that stage to enable us to sort of get through the complexities of designing such a large project. We really wanted to have 2 buildings that were essentially very, very similar in nature, that we could take the learnings from one building and apply it to the second. We didn't really want to have 2 independent buildings on the project. So through schematic design, you know, one of the first iterations of the facade language started to evolve and started to look at ideas of articulation and modulation and very early explorations of the sort of the unitised facade. And I think that was one of our other key things we wanted to bring to it, was looking at ways of doing as much of this project off-site as possible. So, and that was about potentially the structure, thinking about mass timber, the bathrooms, pod bathrooms, and then unitising the facade and really starting to get some intelligence into the design. During schematic design, the way the building was planning out, which is very similar to how it's actually outcome, looking at the left-hand building on the page at the moment. So from bottom to top, there's a communal study space, amenities in green. The pink space is the main common room, and then an entry knuckle, which is the yellow, which runs up through the building, and that's where our main circulation lifts. And then an apartment wing, and this was one of the early iterations of the apartment wing. And essentially this was twinned in the south building. And then in between, some lovely landscaping, working with the existing trees to create this strong residential courtyard. The upper levels is the main planning for the building. So running around the outside of the arc are a series of apartments, and this was the schematic design thinking. This was 4 and 6 bedroom apartments running through the outside of the building. We're running around the inside of the arc, where our SOUs, or single occupancy units, single room apartments. And what was really key, I think, when we started this journey with the 2 arcing buildings, was understanding what the geometry meant and sort of setting ourselves some rules, and knowing that we're working with a radial geometry and never fighting that noise, trying to work to that radial geometry. So always setting out from the radial geometry of the 2 buildings. And then, as you can see, the buildings from the upper levels were twins of each other. Whilst there were some changes in the ground floor conditions due to site levels, the upper levels would be twinned, and that allowed us to get some real repetition into our structure, thinking and services design. So as Jarvis alluded to, it was really during schematic design that we sort of started to bring the mass timber story onto the project. We had Gillies Hall on site, and that's an image of, that was in Frankston, August 2018. And so we started discussing with Duo and the client the ideas around digital fabrication, construction efficiency, that it was an honest natural material, but really importantly that it was, you know, the sustainability credentials, low carbon credentials. And I think ultimately what really sort of putting all of these together, especially the sustainability story, was about LATROBE having the possibility of showing real market leadership. And this, and I can't underestimate that enough when you're going to speak to your clients about taking to them an offering that shows market leadership in sustainability and innovation. And that's a real key selling point. I think that's what kept mass timber on the design through some rocky periods at times. So understanding the journey, because we had been on the journey before with a design team, we understood the complexities. And from probably that point where we were really trying to press go on the mass timber was around about September 2018. And the programs we had on the table at that stage suggested that we needed to have IFC drawings ready to start shop drawings at around about March 2019, which was about 5.5 months. And sort of getting the design team around the table and trying to get everybody to understand that everybody's inputs were required to produce those 2 pieces of information that we needed for the mass timber, which was the CLT setter drawings and the structural certification. Everybody around the table needed inputs into that: fire engineering, building surveyors, services, acoustic requirements, trying to explain to a service engineer that sometime in about 4 weeks' time we needed to know where their fire sprinklers were going to be, what the size of them was, what the pino was going to be through the timber beam, so that we could start to actually work through the design of that with the structural engineers. was probably a little bit confronting, I think, for the design team. But I think the result, the best way to explain it to everybody was that if we carried on as per normal and sort of all designed in our silos and made the sort of normal, not designed in silos, but made the normal assumptions of a traditional procurement process and documentation process, we would end up with a car crash when the D&C contractors were appointed. So it was very much about getting everybody around the table early and coming together fast, so that by the time we got into our tender process, the stage 1 and stage 2 tender, we were all singing from the same hymn sheet, as it were, and on track to achieve sort of aligned and well put together shop drawings. Of course, in every project, things don't ever quite go to plan. I'm saying getting slightly lost along the way. So when we got our stage 2 tenders come back, it was pretty clear that we needed to do a little bit of, we'll call it design consolidation. I think project managers tend to call it value management. And sort of key parts of this were we really looked at the efficiencies of the building. Obviously, as Jarvis alluded to, there was a little bit of an ECI process going on, and how we could get this building back on track and get the budget back on track. And that was a really involved process going on behind the scenes. But for us, it was about pins down. So things were very much up in the air at that stage. On about the 7th of March, I received a phone call from LATROBE, and then from Multiplex probably about 5 minutes later. Jules, who's going to speak after this, and this was on the 7th of March, he said, "We're on," and he said, "Looks like we're on board. Multiplex have LATROBE have given us the go-ahead, and we'd like to have productions. We'd like to have panels in production in 8 weeks." He said, "Do you mean IFC drawings in 8 weeks?" He said, "No, panels in production." So we began an incredibly intense process over that next 6 to 8 weeks to actually get to pull together the tender again, pull together the design story from the tender, and work with Excellent Dolomiti and Multiplex to get our shop drawings and their production drawings and obviously the structural engineers drawings to get everybody aligned so that we could actually get panels into production in a ridiculously short time frame. It was about getting back on the Mac in 6 weeks and literally going from the sketch on the left, which is what we had on the 7th of March. We were still moving around apartments, moving around walls, and trying to get to our IFC shop drawings on the 20th of April. And it's fair to say on the same date, on the 20th of April, this was the production drawings that we had through from Excellent Dolomiti. We ran all of these in parallel. So as we documented our shop drawings, we documented our construction drawings, Excellent Dolomiti was working through their shop drawings. And we did this by sitting around a table, and Jules will go into this in much better detail. And obviously the great thing for myself and Danielle, my colleague at JCBA, this table just happened to be in Trento, Italy. We spent 2 weeks with Excellent Dolomiti, Multiplex and TTW, the engineers, and we went through every part of the building, the set out, the details, logistics, construction, and how we could actually get what was essentially our sketch into production. And I think...
Please keep an eye on time, Simon.
Well, I'll be through in a minute. And I can't sort of stress that enough about in terms of just getting through, actually sitting around a table early. And just a very quick example of that was the knuckle plats, this was the sketch that we'd gone out to tender with. This was what was in our tender documentation. When we got around a table, we had to work out how to do those. And I don't think we could have done this without actually sitting at the table. We took the ramp detail, which was a CLT ramp. It was the inputs from XLAM was about using an 810 by 70 glulam beam for the top of the plat to actually form these central staircases. And it's not something that I would ever have suggested, but it's something that sort of came as it came to pass. It was an input from the design team in Italy and Multiplex agreeing to it that meant we were able to, I think, achieve a pretty remarkable design outcome. I think when we showed them this render, they were concerned that we had showed CLT as opposed to glulam. On site, this was actually taken this morning. There's obviously a fair bit of finishing to go on these, but these to me are a real summation of that. If you can get around the table early with your supplier, especially your supplier and potentially your contractor as well, that's when you can really get the design outcomes you need. And mass timber is not business as usual as we know it at the moment. You have to change the way you think. You have to change your procurement methodology. You have to change your thinking, and if you don't, you're always going to fall over. As Jarvis alluded to, when you start to map out the normal time frame using normal procurement methods, I think you end up with some program dates that, for a lot of programs are generally just unworkable. you have to get your suppliers early. You have to look at ECI process. You have to change the way you think about procurement and about design. And certainly now, sort of second major project, that's definitely the learnings that we've taken from it. And it's, to me, that's one of the only ways you can get sort of these larger projects over the line at the moment.
Thank you very, very much, Simon. And now the word goes to Atreyu.
To everyone listening in, thanks for taking your time out. My name's Atreyu, and I'm an Associate Technical Director at TCW, and I have the pleasure today to present a little bit about the structural design of this exemplar building. I'll talk a little bit about the structural design, but I appreciate we have a fairly diverse audience today, so I won't deep dive too much on the technical stuff. I'll cover a few areas of the design where we have implemented some clever solutions. I'll talk a little bit about structural fire engineering, and probably most importantly talk around the collaboration process with Multiplex and their suppliers, and how that was really essential to the fast track delivery and also unlocking a lot of the efficiencies in the design. So a key consideration for the structural design is looking at the building holistically. We spent a lot of time talking around the timber structure, but there's also a large component of concrete in this building, and as there are in many timber buildings. And being able to view the structure holistically and understand how both of those layers of the layered cake interact with one another is really important to unlocking an optimal design. So one of the key areas we were able to unlock the design, the value in the design is actually in the substructure, in the concrete structure. So there was a reference design, as alluded to earlier. There was sort of two options. Was a concrete option and a timber option that were being considered earlier in the process. And when we came on board with Multiplex through the tender stage, we were able to view the structure holistically and remove a lot of the pile foundations and optimise the transfer structures by considering the structure holistically. It's important that it's worth noting here with this diagram that we see some concrete cores there for vertical transport and egress stairs. A decision was made early in the design process that to eliminate approvals risk associated with those egress paths, that those items should be done in concrete. And so that presented an opportunity for us to really view the lateral stability system as a hybrid system. So it's a combination of the concrete cores working in conjunction with the timber shear walls. And by fine-tuning the stiffness of those concrete cores relative to the timber shear walls, which you can do by varying the size and quantities of reinforcement in the concrete and by varying the number of timber connectors, we were really able to find that sort of Goldilocks moment where neither the timber shear walls or the concrete cores were working too hard. And what that also meant was that the force in the timber diaphragms was also balanced. And so we really managed to save a lot of material through considering that lateral stability system as a true hybrid system. What that meant for us also was that we could then minimise the number of connectors. So down on the right here you see an example of a typical CLT wall connector. This is sort of ties the walls down, so under wind and earthquake loads that the walls don't get uplift. Initially, when we looked at the design, we were finding we needed to have timber connectors on both sides of the CLT walls. That was going to present a coordination risk in the design because one side of these CLT walls is exposed, as you saw earlier in Simon's presentation. Now, there was opportunity to conceal those connectors behind joinery and so on, but we took the decision that wherever we could in the design, make a decision that would eliminate future coordination, that we should pursue that. And so this was one example where we were able to eliminate that coordination risk, which was really essential in that fast track design program. Due to the geometry of the building being slightly outside of the scope of the Australian standard for wind, we had to take a bit of a look at desktop wind studies. There wasn't sufficient time in our design program to undertake wind tunnel tests, so we relied on some further information from Eurocodes and other sources to do a desktop wind study. that was something that's fairly unique to this shape of building. This one's sort of for the concrete munchers. I know we're all here to talk about timber, but a lot of the smarts in the structural design applies not only to timber, but also the concrete elements. And with any curved building, you introduce complexities to do with setting out. And there's some really small wins that can be had by adopting a DFMA approach in the design and the documentation. And this is one small example of that, where we were able to really minimise wastage of reinforcement by designing the reinforcement module around a standard welded mesh sheet. Another challenge was the roof geometry. So if you take an incline and you sweep that around a curve, it produces a curved surface. This is a special type of curved surface, surface of revolution, that can be panelised using flat panels. But again, we took the view amongst the design team that this coordination was going to introduce complexity into the project, and that could really be avoided if we just adopted a flat CLT roof and graded timber battens over with metal sheeting. So on to structural fire engineering. So I'm sure many people listening in have heard the spiel many times around timber charring, so I'm not going to bore everyone with that today. I think you know, collectively that's pretty well known these days in the industry, how timber chars. Instead, I'll talk about the sort of high-level design approach and towards structural fire engineering, and in particular, the understanding disproportionate collapse and structural robustness. So we had to demonstrate that the design complies with the National Construction Code, and in particular provisions CP1 and BP 1.1. And this is really about collaboration with the fire engineer and making sure that there's alignment between the structural fire engineering strategy and what goes into the fire engineering brief. So there's a whole series of controls and a risk-based approach that's taken. And what that means for us is that we need to prove beyond the fire resistance level that the structure still has a general level of robustness, and there won't be a collapse that's disproportionate to the event. So one way that we do that is we look at notional element removal, and this is effectively a Eurocode approach, and we can demonstrate that the structure has that robustness beyond the FRL. A lot of effort goes into this part of the design. Another key aspect of this particular building was to demonstrate that either side of the knuckle, the wings as they're known, could be structurally independent of one another. In the reference design, there was actually movement joints at those locations and twin wall sort of solution. That would have introduced a whole lot of complexity to do with joints in finishes and in facade. So we wanted to eliminate those joints, but maintain that strategy of structural independence. And we did that by adopting the overstrength design principles that's set out in specification C 1.11 of the code. And so we effectively designed for both scenarios where you may have a fire in the knuckle that leads to a localized collapse, and egress is still maintained safely through both of those wings. Alternatively, you could have a fire in one of the wings that goes beyond the 90-minute FRL, which then leads to a localized collapse, and you still need to demonstrate that you have safe egress to one of those two cores. That's really a story around that early collaboration with the fire engineer and making sure that alignment is there. So on to the sort of the real hero of the whole story, which was the collaboration with Multiplex and their suppliers and the broader design team. And this is where we can take a good design and turn it into a really efficient design. The suppliers really unlock a lot of that efficiency and really help us to achieve those lean design goals of reducing waste, reducing cycle time and cost, and improving quality. And we do that by tailoring the design to suit specific processes and the sizes of their CLT panels and thicknesses and so on to optimise it to their system. As was alluded to earlier, we attended workshops with Ex-Lam Dolomiti in Italy, and that was a really intense 2-week period where this collaboration occurred. I think we've seen that photo a few times now. What that meant for us back here in Melbourne was that we were able to unlock a 24-hour work cycle, which was another real key element of the fast track design. So we would receive something like this back every night from one of our engineers, Jane, which was agreed actions from their workshops through the day. We would then test those things structurally, update our documentation and return that back to the design team in Italy for them to continue with their workshops the following day. It was a really intense sort of 2-week period for everyone both in Italy and back here in Melbourne. One example of the value that was unlocked by XLAM Dolomiti was considering the material efficiency. So their standard CLT billet is larger than what would fit in a standard 40-foot shipping container. Usually in a design, you would design the structure around a module that works for a standard shipping container. That way you have a sort of broad range of procurement options. Obviously, at the time that the supplier starts to get involved, you no longer have to have that broad procurement option there. So we can really start to tailor the design and look at different transport options. And so what we did, what XLAM Dolomiti Multiplex did, was to go for an open top container. That really reduced material wastage, albeit it comes at a slight expense that the transport is more expensive. Being an open top container, there's less room on the boat. They have to go on the top of the boat. So that was one really neat example where we were able to reduce the number of panels that were being shipped, reduce material wastage and reduce craneage on site, which ultimately led to a faster build and a cheaper build.
Please keep an eye on the time, Atreyu.
Yep, just about finished. So all of that had to be compressed into an incredibly short program, as you've seen from the earlier presenters. At the design, certification, shop drawing, preparation, shop drawing approval program, everything was on critical path. Meanwhile, it's important to also remember that back in Melbourne, there was a concrete substructure that had to be complete in time for the CLT to be landed. And so this meant we had to run parallel teams to deliver each of those two components. Both concrete and timber was on critical path. And really the success to this, and it resonates with what everyone else has said, is the collaboration and communication amongst the design team was really what led to the success of this fast track program. So I'd just like to finish off by a bit of a shout out to my team, who really pulled out a huge effort to deliver this, and the broader design team who worked really well together. And thanks everyone for your time.
Thank you very much, Atreyu. Please share your screen. And with three great midfielder like you have been, really the greatest, now it's easy for Jules to kick the ball into the goal.
Well, thank you. Yes, there's some wonderful speakers there before me. My name is Jules Tribuzio. I'm with Multiplex. I'm one of the senior design managers here. And I must say, we're going to talk about CLT, fast tracking it, but it's really going to be all about collaboration as far as I'm concerned. We undertook, and I'll probably be going over some ground that's already been covered, but I'll quickly get through this agenda, which will cover the actual documentation, our involvement in the early stages, fast tracking the design, overcoming some of the challenges, and what lessons learned. LATROBE Uni, Jarvis, Simon have already covered off most of the objectives. Really, for us, it was plain and simple. They wanted 2 sustainable, environmentally sound buildings. They needed to house approximately 600 students, and they wanted to complete it by July 2020, semester 2. Admittedly, I'll have to say at this point that had we probably entered a little bit earlier, with an ECI rather than a 2 or 3 horse race tender, we probably would have delivered that by September 1 had we started back in August of 2018. We received documentation, as Simon's alluded to, in November of 2018, and we basically comprised of approximately about, I'd call it a 50% design development tender package, and it came with a very clear design brief as well. That we undertook structural peer reviews with TTW during the tender. And we also developed a design. At the time, the design was quite preliminary, so we had a preliminary rate or provisional sum rate of $1,000 a square metre to chase, which we did with our subcontractors. So the message here that's coming through is that whether it's through tender or through an ECI, we talk about ECI as an early contractor involvement, but I think more importantly, we probably need to start talking about let's call them SEIs, as subcontractor early involvement, because and manufacturer early involvement. That's where the key really is. We also had Wood and Greaves services. I'll just pop back. Runs, as Simon mentioned, they were pretty well coordinated. They had the use of BIM as well throughout that, and we were asked to close a tender on the last day of the year 2018, so we could go off and celebrate a hard year. So basically, again, this is one of the facade module drawings that we undertook, that JCB issued during the tender period, which we adopted. There's some sections to show the scale of the buildings. Initially, it was actually 2 buildings. One was 6 stories, and because of the slopes and the land topography, the other one was 7. And it was housing, as Simon said, 598 students. We've all seen this slide of the knuckle, which was issued a tender for us to put some pricing together. And then basically, once we got to that point and we were given the nod, we really got into the nuts and bolts as to how to get to deliver the client's wishes. And we started our early contractor involvement in March. And our role here was to review, and we also challenged the matrix of the apartments. Of the 598 beds, there were a high proportion of 1-bedroom single occupancy units. With that came a high proportion of bathrooms and kitchens per bedroom. So we sort of started thinking, well, how else can we potentially reduce the cost here? And that's where we started talking to JCB and Duo about the possibility of changing that mix. We also looked at the roof design. Initially, it was sort of falling to both sides. It had box gutters. We looked at deleting those box gutters on behalf of the client's wishes, and we ended up with falls to the inner radius, thereby reducing a lot of civil works as well. So these are the sort of things we look at through an ECI. We also looked at the reduction of that level 1 structural concrete transfer, which initially was for the full floor plate. We cut that back to half the floor plate and extended the CLT load-bearing panels all the way down to ground level. What that did was obviously halve the amount of concrete, which was quite a deep transfer, but also put a lot more pressure on getting the CLT to site, because once that ground floor slab was poured, we could start installing CLT panels. So during the ECI, we too looked at other options to perhaps simplify, and the concept, not knowing that the JCB guys had already been down this road, so that wasn't going too far. And then we got back to really just talking about the potential for more students to assist with the feasibility study. You've seen the slide. It's pretty well tells the story. It's basically an additional 26 apartments. 26 beds, which incorporated into the original number is an additional 5% of rooms, and that was contained within the same envelope. The RLs didn't change. We just took advantage of that slope in the land, and we were able to get original floor was 6 and 7, as I mentioned. Basically now there's only 6 floors in both buildings. These are just some of the ideas that we had during the ECI and the tender as to how to simplify the roof structure, which then evolved into, as Atreyu alluded to, a simplified CLT topping. We also looked at the shafts and just how we could actually build those so that we weren't getting timber into those fire-rated shafts. And we came up with some details there to basically create penetrations that we could fire rate quite easily on site. So moving on, we got to a point where we were discussing CLT in early March, as shown earlier on. We got involved in the ECI, and I felt my role was really just to facilitate that collaboration that everyone's been speaking about. I think that is the key point between the architects, consultants, the manufacturers and ourselves, and just understanding all those competing agendas and where everyone's coming from. And there's a balance there. You need to look at the engineering requirements from TTW's point of view, but also with the manufacturing requirements to streamline the process and the production on the CNC cutting and routing times, standardizing panel sizes like it's already been mentioned, joint types, fixing methodologies, and the transport was all key to logistics. And of course, protection. We made this decision to go with the high top containers. Yes, albeit more expensive, but once covered up, it allows us to get up to nearly 3.3 metres in height, as opposed to the 2.4 metres or 2.35 metres that you would put into a closed container. And then we would protect those as well. We also, whilst we were there, we had to obviously take on board the other interfaced areas and components, and they've also been mentioned, the service pods, the facade types, and the roof. Fire engineering, acoustics, I think they were all pretty well developed at that stage, so that the team was really in a pretty good place, even though the drawings sort of did a bit of a backward step because of the recutting of the feasibility. Everyone knew pretty much where we were heading, and we didn't really change the fundamentals of the design, which is generally what we try not to touch. I think the other key there during the time overseas was the fact that we had real-time, I call it real-time 3D model approval. So we basically made an agreement that we would approve the 3D model as we worked on it, as opposed to document each panel and then approve each panel through a shop drawing workflow process. That would come later, but we needed sign off on the model because it was the model that basically would go into the CNC machine production and get the CLT going within 3 or 4 weeks. And that's pretty much what we did. So basically there's the few weeks in March where we spent in Melbourne before we headed off. We spent 2 weeks in Italy in those design workshops. And I think, I don't know how we'd go in this day and age of the coronavirus and COVID-19, but face-to-face around the table is definitely the way to go about it. That allowed the guys, once the 3D model was approved, to shop draw over 2 weeks till the end of April, at which point they could start production at the start of May, with our first panel arriving on site in Australia in July of 2019. That's not even 12 months ago. So those 2 big bulky buildings you see being basically built from scratch in 2 months, in 12 months. Speaking of which, overcoming some of those challenges, as I said, look, we'd already been down this road. We were lucky enough to have already had one under our belt. Most of us knew each other, but the ones that didn't, they were certainly brought into the fold, and there was a lot of trust. There was no ego, and there was plenty of commitment by the team members, as you can see there from my Abbey Road shot. So it's not just about slogging it out. It's about breaking bread and having that common objective. And basically, we had the right team members there from all parties: JCBA, TTW, Excellent Dolomiti, and Rothablas, the connecting company in Italy. And as Atreyu already alluded to, we had this time warp thing where we actually took advantage of the clock, and with officers back home in Australia documenting overnight while we slept, and vice versa, obviously. So we've really pretty much compressed a month into 2 weeks, basically. The shot's been up a few times because in essence, it's what made it happen. It was us around the table every day, discussing, collaborating, having a break when it all got too heated. Espresso coffees would come in, cakes. It was it wasn't short of being
Jules,
nourished.
please be mindful of the time and please illustrate some lessons learned. I know you have some very interesting ones.
Yep, well, this is all part of it. Collaboration, and we're coming through to what Paolo's alluding to. Within the 2 to 4 week period, we basically had the shop drawings for the CLT ready to go, and that could start production, as I mentioned earlier on. working through most of these details. Some of the lessons learned, Paolo, were basically services reticulation. We knew we had to have enough contingency in there, so we allowed penetrations for services, not just in the CLT, but also in the glulam beams were part of the structure. And we had the structural ability to approve those whilst we were doing it. There they are again on your left of the slide, going through some of the glulam beams, and once again another shot of them there. So the knuckle was the other area. The knuckle, is quite a complicated little area, so it took a bit of time. But we did that within the 2-week period we were there. Also, we made the decision to land these, as Simon mentioned earlier, as a flat panel, inclined to the slope, and then come back and basically introduce the plats for the seating at a later stage. And that's the result of it there. So it looked quite nicely all lit up at night, I'd imagine. So the lessons learned there were services. Then we move on to the facade, the modularised facade. Having delivered a previous similar project down at the peninsula for the other university, Monash, we actually installed that as a stick frame with scaffolding right around the building. We realised that the modularised unitised facade was the way to go here, which of course eliminated all that scaffolding and time required. And it's really in keeping with what was originally planned, 6 months prior. So we ended up with a lovely result. I think the colour choice there was, you can choose up to 12 colours, JCB, and they certainly did that. They've come up with a treat of a facade. I think it looks lovely. I think it's referred to the butterfly facade, given the shape. So I think other lessons learned, I think you need to ensure that other building elements are given the same fast-track commitment to align with the program, and also be left behind. And that is that, bathroom pods, whether it's the facade design, but it is an extremely fast-paced delivery style. So look, the winning result is we are on track to deliver it as contracted by July 2020. And it's really been an amazing ride. It's due to our dedicated site team, which has been led by a dynamic Danielle Sabio out there, who couldn't be with us today, unfortunately. So even through the adversity of Rona, we're still going to get there. Stay safe, and thank you very much.
Thank you, Jules, and thanks to all the 3 other speakers, Jarvis, Simon, and Atreyu. You really did deliver an excellent series of contents, and I can tell you we still have 417 people online following you, so you really captured everybody's attention. We had over 440 in the peak. And so I will welcome you to pick up one question of the many that you received and answer it quickly, but then we will make sure that with a week of time, we will answer in the written form with quick and brief written answers, all the questions, because there are many and they are interesting. And we will post them together with the recording of this webinar. So please, another 5 minutes. There's still over 400 attendees online. The 4 of you pick a question each and answer it, whatever you like.
Well, one of the questions there is, if you don't mind, is regarding the facade. And the question is, was there any timber or CLT incorporated within the facade? No, it needed to be the answer is no. It needed to be a non-combustible facade. So therefore, the facade as a modular construction was actually made out of steel frame, well insulated, with aluminium and glass windows.
I will say Atreyu. So let's go backwards. There's many questions for the structural engineers. Pick one.
Yeah, I'm just typing out a few responses. Maybe circle back around. I'll pick another one to talk to.
Okay, Simon?
I can talk at a high level. There was a couple of questions about fire rating and asking about whether the fire engineering solution used and is the building sprinklered. At a very high level, yes, the building is sprinklered. The fire engineering, it essentially follows the deemed to satisfy provisions of the BCA. It's beyond that. It's a really complex story. You know, the panels. The panels between the SOUs, one side of the panel is exposed, the other side isn't exposed, and it's got fire check directly stuck to the panel. We've probably exposed about 50% of our wall panels on the project. We've exposed virtually none of the ceilings, and that was really around a fire loads issue. So whilst we could get a deemed satisfied solution by exposing our ceiling panels, the fire engineers were really concerned about essentially the fire loads and how much timber we're bringing into the building. So in our corridors, for example, we've exposed one side of the corridor wall, and that was, the fire engineers were comfortable with exposing one side of the opposed to two, and that was about fire loads. And the doors in the corridors are full height, which is about providing a fire break. So essentially it's always about, there's one about FRLs, give you time to clear out the building, but the fire engineering strategies of a building like LATROBE are really also governed by how well and how easily the fire brigade can actually fight the fire. And I think Atreyu alluded to the design of the knuckle in relation to the two wings, the two locations of the fire stairs. And it's certainly one thing we've learned doing Gillies Hall in this building. It's never apples for apples. It's apples and oranges, and every building's going to be a little bit different. And you need to get that understanding and your fire engineer, good fire engineer aligned really early on in the process to work through that, because it is one of the most difficult things probably to work through.
Wonderful. And Jarvis, any favorite question that you picked?
They're all pretty technical. It's sort of
they're good, really good.
I know a couple, I think. So in terms of the sanding, it was sanded prior, as I understand it. So there's no real on-site sanding unless there's sort of a defect or a ding or a bang. I'll try and take a structural one. I think the XLAM Australia would have had a similar structural performance, if not the same, to the one overseas. Atreyu could probably correct me if I'm wrong there.
Yeah, I mean, there's nuance between the various suppliers in terms of the material grades and stiffnesses and their standard panel sizes and so on. But broadly speaking, the product is fairly standard around the world. Look, the decision for the procurement was obviously a multiplex decision. It wasn't based on any design. And there's a couple of questions there, sort of confusing XLAM Australia with XLAM Dolomiti. They are two separate entities. They just share the same namesake.
Okay, so I guess overall you did deliver a very, very good result from your professional activity into this job, as in many other jobs that you have been doing and are doing up to date and in the future. And you did deliver a very, very good result and very good value for the attendees today. We still have just a little bit below 400 online now. So you're really excited, a lot of people. And let me tell you, if every one of these guys has a timber project in the future, our job is guaranteed for the next 10 years. But most importantly, our future will look more sustainable for all of us. So thank you all, guys, very, very much. I will see you into the next webinar, which is in a week. And please stay with us, stay safe, stay happy into these challenging times, which also provide us with interesting opportunities. I'm thanking once again the 4 speakers, which really deliver a very, very good result today, and see you next week. Thanks.
Thanks, everyone.
Thank you, guys.
Thank you.